Okay, this lesson is on section 4.9, our introduction to antiderivatives. And antiderivatives are just the opposite of derivatives. It basically means that you take the function that you're given and say that it is the derivative, and figure out what function it is the derivative of. And for easy ones, you can kind of think through it. Suppose f of x equals 3x squared, and that's the derivative. What would be the function f? Well, we know that this 2 comes from reducing it by 1, so it must be an x to the 3. And if you figure out that much, you can see that the derivative of x cubed is 3x squared. So this is known as the antiderivative. Because the derivative of a constant is 0, though, our function could be the function x cubed plus any constant. So it could be x cubed, or it could be x cubed plus 1 or 2 or 3 or 4. So all of these two have the same derivative. So when we do antiderivatives, we have to state the antiderivative of f of x this way. And we have to add a constant c to the end of it because the derivative of c is 0. All right. So a function f is called an antiderivative of f on an interval I if f prime of x equals f of x for all x in I. So the most general antiderivative of f on I is f of x plus c, where c is any arbitrary constant. So here you can see that this family of functions x plus c all have the same or these are the derivatives of the same function. And same thing here. So there is a rule for finding the antiderivative. You don't just have to think through it. There's a rule. This is the basic rule. I call it the power rule. The general antiderivative of f of x equals x to the n. So if you have a function and it's just a nice polynomial with a power, as long as n isn't equal to -1, there's a different rule for that, then the antiderivative big F of x is, the first thing you're going to do is add 1 to the exponent. So that gives you x to the n plus 1, and then you're going to divide by that same exponent. X to the n plus 1 over n plus 1 plus c. This rule is valid as long as n is not equal to -1. There's another rule for n is not equal to -1. Alright, so just practice this really quickly. So if we have f of x equals x to the 6th, then the antiderivative is going to be x to the 6th plus 1 over 6 plus 1, which is x to the 7 over 7 plus c, or 1/7 x to the 7th plus c. Okay, so what if n is equal to -1? Well, if n is equal to -1, your function is going to look like this, x to the -1. And if you try to use this rule, you'll find out really quickly it's not going to work, because if you add 1 to -1, you get 0, and then you would divide by 0. You can't do that. So there's always a way to think through it. Like if you try it and forget, it's not going to work because you can't divide by 0. So what is the antiderivative of x to the -1? It's the natural log of x plus c. And you see these absolute value bars? When we go this way from derivative to antiderivative, we need the absolute value bars. WebAssign is going to want that because this value right here, there's a domain restriction. It must always be greater than 0. So we need to, since we don't know what x is, we need to protect it and say, okay, this has got to be greater than 0. So absolute value bars ensure that, and then plus c. so here is a table of antiderivatives that you want to memorize. And so if you have a constant, so that rule I just told you, if there's a constant being multiplied, then it just comes down. So we've been doing that. The constant just comes down, and then you use the power rule. This one is saying that if you have two functions added together, you can take the antiderivative of each one individually. Again, that's just like derivatives. And here's the power rule we were talking about. And here is the antiderivative of 1 over x, where x is -1, is natural log of absolute value of x, and all of these are plus c at the end. The antiderivative of e to the x is e to the x. Okay. The antiderivative of a power, like 2 to the x, would be 2 to the x divided by natural log of 2 plus c. And then your trig, the derivative of sine is cosine. So the antiderivative of cosine is sine. And the derivative of cosine is negative sine. So the antiderivative of sine is negative cosine. The antiderivative of secant squared x is tangent of x. The antiderivative of secant x tangent of x is secant of x. The antiderivative of 1 over the square root of 1 minus x squared is arcsine of x. All of these are plus c. And the antiderivative of negative 1 over the square root of 1 minus x squared is arc cosine of x. And the antiderivative of 1 over 1 plus x squared is arctangent of x. And the antiderivative of negative 1 over 1 plus x squared is arctangent of cotangent. Okay, so let's practice a few. It says find the most general antiderivative for each function. Okay, so we're going to call the antiderivative big F of x. Alright, now this is a constant. So there is x to the 0 power, so we can use the power rule for here, but it might want to memorize that. If you have a constant, the antiderivative is just going to be for whatever the variable is for x. Because see, the derivative of 4x is 4. Okay, next one, we're going to take the antiderivative. So remember, we're going to add 1 to the 2 first, and then you're going to divide by that, and that would be 1/3, or just divide by 3. Alright, here this minus 5 times x cubed minus 5 is a constant, so it comes on down. And then we're going to add 1 to the 3, that's x to the 4th over 4. And you can clean that up. And I didn't forget, but you should be thinking about this. This is minus 5/4 x to the 4th plus c. That's what you always want to check for. So I have a lot of students, when they're getting ready to take a quiz, they write up at the top plus c to remind themselves, because you'll lose a point if you don't remember that this is the family of antiderivatives for this function. Alright, let's try another one. So we have f of x equals 3e to the x plus 7 secant squared x. Alright, so big F, that signifies that we're taking the antiderivative. Okay, this is a constant, so it comes on down, and the antiderivative of e to the x is e to the x. Plus, alright, here's another constant being multiplied, so that comes on down, and the antiderivative of secant squared x is tangent of x. And then we have a plus c. Okay, so in some cases we're going to find a more specific function given knowledge about its derivatives. An equation that involves the derivatives of a function is called a differential equation. The general solution of a differential equation involves an arbitrary constant at plus c, but if you are given more information, you may be able to find that value of c. Okay, so let's start with this first one. This first one, you're given a second derivative. And so we want to find f of x, which is the original, I call it the original function. So we have to work backwards. So if we have the second derivative of f, we can find the first derivative by taking the antiderivative of cosine. And so when you're taking the antiderivative of cosine, it is sine of x, but then you have that plus c. Okay, so then to find the function f of x, we're going to take the antiderivative of sine of x, and the antiderivative of sine of x is negative cosine of x, and the antiderivative of some constant c is cx. So if you have a constant, that's the antiderivative, but then there's another constant d. So that's how you can take one antiderivative to get to the first derivative, and then another antiderivative to get the second derivative, the original function. All right, so that's that one. All right, now let's take a look at this. These are called fixed value problems. So this f of 1 equals 6 is additional information that we're given. It's an ordered pair 1, 6. It's on the function we're trying to find. So if you're given the derivative, you can find the original function if you take the antiderivative. Okay, so that's step 1. So 8 comes down, and then we're going to, so 8 comes down, and then you're going to add 1, so that's x to the 4th divided by 4, plus, then we're going to, constant comes down, and then we're going to add, there's a 1 there, so we're going to add 1 to 1, that's 2, and divide by 2. And then there's a constant 3, so remember the antiderivative of a constant is just 3 times whatever variable you're given, so if that's not x, don't put x there. And then plus c. So that's step 1, and we'll clean this up. So this is f of x equals 2x to the 4th plus 6x squared plus 3x plus c. So this is the family of functions that have a first derivative of this. But see, then we're given a fixed value. We want to find the one function that passes through 1, 6. So we can use this point to find out what c is. And we do that by putting 6 in for f of x and 1 in for x. Okay, so that gives me 6 equals 2 plus 6 plus 3 plus c. That gives me 6 equals 11 plus c. And then c is equal to negative 5. So we now know exactly the function. We don't know just the family of functions. We know that this exact function is 2x to the 4th plus 6x squared plus 3x minus 11 because it goes through that specific point. So that's how you find the exact function if you're given a point. It's called a fixed value. All right, let's try another one. Okay, so this time we're given the second derivative, and then we're given a point on the original function, and we're given a point on the first derivative. Okay, so the first thing we need to do is find the first derivative, which is the antiderivative of the second derivative. So the antiderivative of 4 is 4x. The antiderivative of minus 6x is minus 6x squared over 2. And the antiderivative of minus 40x cubed, minus 40 comes down, and then x to the 4th, add 1, divide by 4, and then we have the plus c. So if we clean that up, we have f prime of x equals 4x minus 3x squared minus 10x to the 4th plus c, but we're given a fixed point. So we'll put 1 in for f prime of x and 0 in for x. And this time, because it's a polynomial, when you put 0 in, all that goes to 0, and that's c. That doesn't happen all the time. That just happens if you have the right conditions, so don't always assume that that number is c. But anyway, so now we know what f prime of x is. It is 4x minus 3x squared minus 10x to the fourth plus 1. And we'll do it again to find the original function. So the anti-x4 comes down, x to the add 1, that's 2, divided by 2. Minus 3, that comes down, add 1, that's x cubed, divided by 3. Minus 10 comes down, x to the fifth, divided by that 5. And the antiderivative of 1 is 1x plus c. But we know that we have a fixed point 0,2 on f of x, so we'll put 2 in for f of x, and again we'll put 0 everywhere else. So I'm going to simplify that. That's 2 times 0 squared minus 1 times 0 cubed minus 2 times 0 to the fifth plus 1 times 0 plus c. Okay, so we have that. So again, this is just because the conditions are right. We put 0 in all these polynomials. That doesn't happen if you have an e function or a natural log function, so be careful. So 2 equals c, honor the process. Alright, so our final function is f of x equals 2x squared minus x cubed minus 2x to the fifth plus x, and then we found out that c was 2. Alright, let's see about this one. It says f prime of x equals the fourth root of x cubed plus 1 over x squared minus 1 over x. So before I take that antiderivative, I need to get rid of the radical, and I also need to get rid of the negative exponent here. I don't necessarily have to do it here. We'll talk about why. But so I'm going to rewrite this. So f prime of x equals, you already have an exponent there, so don't put a x cubed to the 1. It's the exponent is there, so that's just x to the 3/4. And then 1 over x squared is just 1x to the negative 2. And then you could rewrite that if you want, but that's x to the negative 1. But remember, there's a special rule when the power equals negative 1. Okay, so the antiderivative of this is going to be, alright, now we're going to get complicated with this fraction, so I'm going to show you what we're going to do. We're going to add 1 to this. That's adding 4 over 4. So that's x to the 7 over 4. Alright, I'm going to do it the long way, but I'm not going to want you to leave it this way. We're going to divide by 7 over 4. See, that creates a complex fraction, so we don't want that. So instead of dividing by 7 over 4, remember that dividing is the same as multiplying by the reciprocal. So when I have a exponential power, instead of dividing by 7/4, I'm going to multiply by the reciprocal. Okay? Alright, so this one, we've got x, and we're going to add 1 to negative 2. That's negative 1, and we're going to divide by negative 1. Alright, now remember this one, if you try to add 1 to negative 1, you get 0, and you can't divide by 0. So that should remind you that there's a different rule here. The antiderivative of x to the negative 1 is natural logs and minus natural log of the absolute value of x. And we don't know what constant might be there, so plus c. So this is f of x equals 4/7 x to the 7/4 minus x to the negative 1 minus ln of absolute value of x plus c. Okay, so let's take a look at a velocity and position problem. So it says, suppose an object moves along a line with a known velocity of v of t for t greater than or equal to 0. Well, we might remember that its position is found by solving the initial value problem, because we might remember that, let's just write it down. So we've done this before. So if s of t is our position function, and let me just give you some units. Let's say it's just in meters. All right. Then when we take the derivative of the position function, s prime of t, we might remember that that gives you the velocity. And the units are always y units per x units. So the y unit is meters, and t right here is seconds. So we have meters per second. Well, if we take the derivative of velocity, or the second derivative of position, that gives you acceleration, and that's meters per second. The y units are meters per second. That's the y units per second, so that's meters per second squared. Okay, so if you might want to think about that and remember that. So now what we're going to do is we're going to basically go backwards. So for this problem, we are given a velocity function, and we want to go backwards to get to the position function, which means we're going to need to go take the antiderivative. So if we go down, that is taking the derivative. But if we want to go back up, we're going to take the antiderivative. So we're going to take the antiderivative. Okay. All right, so its position is found by solving the initial value problem. S prime of t equals v of t, so S of 0 equals the initial position. Okay. If the acceleration of the object a of t is given, then its velocity is found by solving the initial value problem. V prime of t equals a of t, and v sub 0 is the initial velocity. Okay, so let's look at this example. It says a particle moves in a straight line and has an acceleration of 6t plus 4, and its initial velocity is v of 0 equals negative 6, so that's a point, and the unit is centimeters per second. And its initial displacement, that's another point, but that's on the position function, is S of 0 equals 9 centimeters. Find the position function S of t for the particle. Okay, so we start out with a of t equals 6t plus 4, and by the way, we know what the units on this are because we're given seconds and centimeters, so this unit would be centimeters per second squared, and we want to go backwards until we find the position function. So to go from a of t to v of t, we need the antiderivative, so v of t is equal to the antiderivative of 6t is constant comes down, t squared over 2, and the antiderivative of 4, remember we got to use the variable, don't put 4x, the variable is t this time, so that's 4t, and then we have plus c. But we know that the initial velocity is, when t is 0 seconds, the velocity is negative 6, so we have that point 0, negative 6, so we can find c. So we'll put negative 6 in, that's 3, put in 0, alright, and so we have negative 6 equals c, so v of t is equal to 3t squared plus 4t minus 6, and we know the units for the velocity are centimeters per second. Okay, so that's our velocity function. But we still want to find the position function, so we're going to take the antiderivative again. So that would give us position function. So the antiderivative of 3t squared is 3t cubed over 3 plus 4t squared over 2 minus 6t plus c. But we know that we are given the initial displacement, S of 0 equals 9, so we know the point 0, 9. So we can put 9 in for S of t and 0 everywhere else, which that's going to give me 0, 0, 0, and then c, so 9 is c. So S of t equals t cubed plus 2t squared minus 6t plus 9. Okay, now catch your brain. Don't let your brain make a wrong assumption. This number 9, 0, 9 is not always going to be c. You have to go through the motions. Now I started to just understand that if you're given a polynomial and then you're putting 0 in here, those are all canceled out. But that won't happen if it's not 0. If you were given 110, that wouldn't work. You'd have to do find c with algebra. If you're given an e to the x function, if you have 0, it won't work. So make sure that you think through the process. It's just don't automatically assume that this number right here is c. All right, so there is our position function. Okay, so that's the end of the lesson. Now, they're definitely a good idea to practice, so if you want to keep going, you can pause the video right now and practice these. You can find the antiderivative of these and then unpause the video and I'll reveal the answers. So you can do that now. Okay, so if you practiced, here are the answers to all of these. So the first one is, get a piece of paper here that's blank, it's better. Alright, so the first one, the antiderivative of 4x cubed is x to the 4th. And the antiderivative of 5x to the 4th plus e to the x is x to the 5th plus e to the x plus c. And the antiderivative of the next one is x to the negative 5 plus sine of x plus c. And the next one is x to the 2/3 plus cosecant x plus c. And if you need to see why, right here, this constant comes down 2/3. And then what I do is I just leave a little space. Whenever I see an x, a power that's a fraction, then I know I'm going to have to multiply by the reciprocal, so I leave a little space. So that's x, we're going to add 3 over 3, so that's 2/3, and then I'm going to divide by 2/3, but that's the same as multiplying by 3/2. And that's how, so 2/3 times 3/2 cancel, and that's how you get x to 2/3. This one you just have to memorize. Alright, the next one, did you catch it? 1 over x, that's a natural log of absolute value of x, and then these are tricky to remember, but 1 over 1 plus x squared, that's just inverse tangent of x plus c. Alright, at number 5, 1/4 x to the 4th minus 1/7 x to the 7th plus c. Number 6, e to the x minus x to the negative 1 plus c. Number 7, 1/5 x to the 5th minus x squared plus 5x plus c. Number 8, negative cosine of x plus sine of x plus c. Number 9, 1/3 x to the 6th minus 7/4 x to the 4th minus x plus c. Okay, here's another one. Now this one has a 3 in it. So that 3 is a constant. It comes down. And then the antiderivative of negative 1, so there's a 3 times, you can think of it like that, and that is inverse cosine of x plus 5 e to the x plus c. And then this next one, negative 1/5 x to the negative 5 minus 1/3 x to the 6 minus 9x plus c. Alright, and then the last one you have to do some fixing of this, so that's negative 3x to the negative 3 plus x to the 1/4 plus 5 e to the x. So the antiderivative of negative 3x to the negative 3 is negative 3x to the negative, add 1, I'm sorry I didn't put the right number there, that's negative 3x to the negative 4, so add 1 you get negative 3, if you divide by negative 3, that's how you get 1x to the negative 3. This next one, again, I like to leave a little space because I have that fractional power, so add 4 over 4, that's 5 over 4, divided by 5 over 4, 5 over 4 is the same as multiplying by 4 over 5, so that's my little trick, just leave a space when you see a fractional power. And then the antiderivative of 5e to the x is 5e to the x, and then plus c. Alright, so I'll see you guys next class. Have a good day.